So I'd like to take this opportunity to show you how to do an APTT test with the Stago Start. How we start, we're going to go ahead and we're going to prepare our reagents according to manufacturer's inserts. What's kind of nice is that with many of the PTT reagents, they're already reconstituted for use. However, anytime that you open these reagents, you should date and time them so that you know how long they're valid for and when they would expire. So for the PTT test, I guess because there's two T's, there's going to be two reagents. The calcium chloride is the reagent that will go into your 37 reagent heating block, which is going to heat it up to 37 degrees. And what's different than the other tests that we would typically do as a screening test is that we're going to be adding the patient or control into our cuvette and then our reagent and allow it to incubate for a little bit of a longer time. So that's a difference. And then we're going to be adding our calcium chloride, which is returning the calcium into the system so that in our sample we can get a clot. Because during the collection of our light blue top tube, we removed the calcium to prevent the initial clotting. So we're going to go ahead and put the cuvette into its heating area. We're going to go ahead and we're going to add one of those metal beads into each of the cuvettes. And we're going to go ahead and then program the computer so we know which samples we should be putting into each cuvette. So we're going to go into test mode. There's one, enter, and it's to do the APTT, we press number 2. And we hit enter, and then our first patient, or in this case our quality control, is 6957. And again, the computer knows we're going to do it in duplicate. And then patient 2 is our high control, which is 7117, enter. And again, it knows that we're doing it in duplicate. I'm not going to show you any patients today, but you would do something with their medical record so you know what patient is associated with which cuvette spot. So now the computer and analyzer is setting itself up so it knows what test we're going to be doing and what samples are going to go into what cuvette. And so for this test we are using 50 microliters for each of the steps. So the first thing we're going to do is we're going to add our actual sample, either a QC sample or patient sample. And remember, you should be handling your QC just like your patients. So I'm adding 50 microliters of 6957 into spot 1 and also in spot 2. Since I'm using a different sample, I'm going to go ahead and change my pipette tip to avoid any cross-contamination. So in wells number 3 and 4 of this particular row of cuvettes, I'm going to be adding the 7117 in spot number 3 and in spot number 4, changing my tip. So now what is required is that we are going to go ahead and add the reagent. So this partial thromboplastin reagent, we're going to go ahead and add 50 microliters. Always be checked with that you have the right pipette and at the right volumes. I've seen students not have the right metric system of volumes or grab the wrong pipette. So go ahead and put this reagent in each of the wells. and then hit the timer so that the timer will go, in this instance, for 180 seconds. And that will ensure that there's been enough time for the patient sample or QC to interact with this reagent and to get up to 37 degrees. In a more computerized or automatic analyzer, all of these steps, you would have actually robotics that are doing the pipetting and setting the time and make sure that everything is at proper temperature. But this analyzer is nice because you get to do the different steps that seemingly magically happen within your typical clinical coag analyzer. So it's now beeping, letting us know that it's almost ready to be tested. So now we can quickly put our cuvette into the test area that is still also at 37 degrees. Some people like to even move it there earlier, but that's how the SOP is written. So now what we're going to do, again, this is the hard part, we're going to now add calcium chloride that's returning the calcium so that this solution can clot, and we're just detecting how long that takes. So we're going to add 50 microliters. Again, this is the hard part. You have to make sure you get a good volume, and then you're going to, as soon as you dispense it, you're going to push the button. And I'm hoping that I do a good enough job that I don't get any stars. Because I want to get within 5% precision between these duplicates. And so you can see in the window, again, this little pipette tube that has this little ball going back and forth, back and forth. And again, this is testing a different part of your cascade, so it just naturally takes longer to go through the clotting process in order to get a clot and stop that bead from going back and forth. So my normal sample is 29.6 and a 20.0, at least a little bit closer than I have been. We'll have to see if it's within 5%. If you're good at math, maybe you can tell me before I'm waiting for the printout. Again, my high control will give me longer. I have a 51.6 and a 50.2. So now you have your printout. And again, no stars. That means that result is good. If you have stars, you have to repeat. And no stars, these results are good. And so we're going to go ahead and we're going to compare our results to the lot number for the various controls. So when we're dealing with the normal control assay, it's very, very important that we find the proper control and lot number, and it's sometimes you have to search on the insert, and then you have to find the right reagent that you're using, and then so I should have had anywhere between 25.9 to 33.9, and so my normal control, yay, is in. And so then with the high control, again, I'm looking to make sure that I have the proper lot number, and so then looking for the test and for the reagent that I'm using, I should have been somewhere between 49.2 and 66.6 seconds. So at 50.9, yay, I'm in. So if I were running patients' results, I could, with confidence, report that information. So this is, I hope, is a good overview so that you can do this yourself during student lab.